how this works. But write today's date on there, even though this isn't our math journal. What's today's date, Dom? February 16th. And today, I'm just going to write this up here. You don't have to write this down, but we're reviewing partial products. And I think I have the wrong thing up, but that's okay. We'll record this one and we'll talk a little bit. Now, if we look at this problem on Bridge Book 131, can anybody volunteer to read number 1 for us so we can figure out what we're going to do here? Anybody named Elian? A little louder, though.
You said anybody named Elian.
You're the only one we got. Just read.
Mrs. Hill's preschool classroom is 16 feet wide and 28 feet long. She is planning to divide it into 4 sections. Here is her plan. Use a multiplication equation to label the area of each section in square feet.
Very good. So we have 4 sections. So we have 4 sections that we can figure out the area of and then combine them all to get the grand total of the area of the giant rectangle. What way can we multiply 16 and 28 in 4 different sections? How can we split these numbers up into more manageable things to use? Rev?
Using the box.
Using our box. Well, it's partial products technically, so it's a slightly different. Zach?
You could split it into 20 and 8 and 10 and 6.
20 and 8 and 10 and 6. Correct. And that's kind of what Rev was talking about also. But with the box method, we just put products in there. With the partial products method, we write an equation. So for this rugged area, Miss Fitch, what would the equation be for the rug area? What would the equation be for the rug area with our numbers? Any idea? Clara, what would the equation look like?
20 times 10.
Close. 10 times 20. Keep going. The whole equation. That's just the expression. Equals 200. And what will we write in the table section? Trevor? What would that area be? What would that expression look like?
It would be
What do you think? If we had a 20 on the... Say it again?
8 times 10.
Close. 10 times 8. I like to use the numbers on the left. What does that equal, Chase? 80. And how about the art area? Dom, what would that be? What would the equation or expression look like?
20 times 6.
Again, we're close. It's 6 times 20. 6 times 20. And what would that equal?
120.
Close. There's no number called 100. 120. Yep, that's a 1. So it's 100. And the library corner. What would that expression look like, Rev?
6 times 8 equals 48.
Very good. A little rhymer. Now that we have the areas of all 4 sections, we can put that into a different type of expression. So what would the area be of the 16 by 28 room? Well, how are we going to figure out the total area now? Mr. Moose?
We're going to add all of them together.
All them. What do we call those? If this is partial products multiplication, those are all what?
Sums.
Nope. Those are all what? They're partial products. Partial means part. 200, 120, 48, and 80 are all parts of the final product. So line up your numbers into a nice addition problem, either one big one, a couple smaller ones, however you want. This would be just the way we would add them all up. And if we add them all together, what is the overall area? The length times the width. This is the area model of multiplication, Mr. Cole.
448
Keep going. 448 area model
inches square.
square feet, not inches. This is feet. That's the foot symbol. Square feet, length times width. Length times width equals A. The length 28, whoops, sorry about that, times the width, 448 square feet. Very good. Now down at the bottom, you'll be able to do that lickety split. Turn the page over. Let's take a look at the back side. Now in here, Elliot, since you did such a good last time, can you read number 3 for us? On my camera glitches.
Sketch an array for each of the frames below. Label each part with a multiplication equation to show its area. Then find the total area of the array.
Very good. So we need to sketch a frame. A frame is just a fancy word for a what?
Box.
A box or a rectangle. So make your rectangle. What's your rectangle going to look like? I don't care where it starts. They already started you out. Make your rectangle. Doesn't have to be perfect, but it should look somewhat like a rectangle. And then we need to divide it into our sections. So 26, what's that made of? Of what two numbers equal 26? Very good. 20 and 6, and they're represented by those two numbers. Each one of these long lines mean 10. 10 and 10 is 20. How about 13? That one's not quite as obvious. Dom? 10 and 3. And now when you divide this up, ideally you don't want it to be a perfect plus symbol. You want some sections larger than the other. So in this frame, which box would be the largest?
The box that has 20 and 10.
The 20 and 10. So what I usually tell the kids is to draw the vertical line where those dashes start. So that gives us a good length. And then draw a line right here. And that separates it into areas that represent larger sections and smaller sections, because the 3 times 6 will give us a smaller number. What's the expression going to look like in our first box here? Moose?
10 times 20 equals 200.
Very good. How about the next one to the right, Viv? What will that expression be?
10 times 6 equals 60.
Correct. And with this area model, we write the expressions in it. How about this box? What's that going to be, Hallie? What's going to go in this one? What expression?
10 times 20
Yep, equals.
60.
Correct. And the last one. Pitch.
3 times 6 equals 18.
Very good. Now what do we do? Zach, what do we do next? We done?
No.
What do we have to do?
We have to
Add up our partial products. Add our partial products, as they are all part of the product. Either one problem, several problems, however you want. What could you do with the 260s? Combine them. Then you only have to add 3 numbers. That's up to you. So what's the total area of this rectangle? Now we don't have a label, so we're not doing inches or feet or anything. It's just the number. What'd you get, Delaney, when you added those up? What? 338. Is that right? Is that right? I don't know. I think she said 338. Yes, good, thank you. 338. So total area 338. All right, so on the next two down there, you're gonna do the same thing. Fill out the bottom, and then on 134, if you get that far, go right ahead with our magic crazy math puzzles, and then I will let you know when you can start your home connection part of your assignment along with your computation sheet. Questions? All right.